All right, Matt, you're ready to go. Just make your slides full screen so we can
Yes, sir.
see the side.
All right, good to go?
We are good to go.
All right. Good afternoon, everybody, and thank you for coming to our presentation. We're here to present the I-12 US 90 to LA 59 Bridge Widening Project as our Class of 2020 Capstone Presentation. We are the Bamberg Builders. My name is Blaine Johnson, and I'll let the rest of my teammates introduce themselves.
Nicholas Ayers.
I'm Mason Bamberg.
Chloe Wallace.
And I'm Matthew Wilkins.
Okay, so here's the overview of our project. Right now, you're looking at the index of sheets given to us by the state of Louisiana Department of Transportation. And right below, you can see the layout map. Our project is located in St. Tammany Parish, Louisiana. And if you're familiar with the area, it's just north of New Orleans across Lake Pontchartrain. And for this project, our role is the independent cost estimator. And our objective is to build 3 bridges at 3 separate sites and widen the roadways around them. So as independent cost estimators, we're responsible for the bid work for demolition, construction, and the closeout of the project. And for the construction portion, it will consist of earthwork, asphalt concrete, Class 2 base course, bridge widening with AASHTO girders, column and power bents, and concrete medium barriers. So for the project, we will use Primavera P6 for our scheduling, and we'll also use HeavyBid for our estimating. And as I stated before, the project consists of 3 separate sites. So I took a few screenshots from Google Maps and I edited them so I can get a more detailed view of what sites we're looking at. So this is the first site. This is I-12 over US 190. And this is from west to east. This is the beginning of the project, and it's located at log mile 9.970. This is the next site going east. This is over Ponchitolawa Creek. And this is approximately 1 mile past the beginning of the project. And this is the last site. This is I-12 over Canal and the Bike Path. This is located at log mile 12.993. And this is the last stop for the project. So this is the basic sequence of construction. And to the right, you can see all the components that go into the bridge itself. So the first step is removal of existing, and that includes the demolition of the abutments, the wing walls, the partial bents, and includes removing the slab. The next portion is the erection, and that is erecting the power bents, the columns, the girders, and erecting a new slab deck. And that portion is basically reconstructing the bridge that was already there and then adding some more onto it. And then the last part is the completion or the closeout, and that includes polishing and finishing and cleaning the site. And once all of that is said and done, then we hand the bridge back to the public.
So for this project, these requirements that we have been given are like Blaine previously mentioned on the Ponchitolawa Creek and the Canal and the Bike Path. The estimating software that we were required to use is HCSS HeavyBid, and the scheduling software that we used was Primavera P6, and it was to be submitted on PM. We had a total estimate cost of 12,578,000. this is the removal of the bridge deck. As you can see, this is a screenshot of the drawings. This is the eastbound. It's bit number 2. This is the I-12 over US 190. We will be saw cutting for this demolition part of the bridge. The shaded portion, it's approximately about 12 feet that we will be saw cutting and removing on the interior side of the eastbound lane, and the westbound lane will be mirrored as well. So this is the I-12 part over US 190. So you can tell that we will be adding the shaded portion again. That's the new construction. 3 columns are existing right now, and then they have a bent cap. However, we will be adding 2 columns on the eastbound lane and then 2 columns on the westbound lane. There will be a bent cap that is placed on top of those columns. The columns are about 12 feet apart. So after the bent cap, we'll have the girders, and there are 3 girders that we will be placing on top of the bent cap, on placing the slab deck on top of the girders, and we'll be connecting it to the existing rebar by mechanical splicing. Then after the slab deck has been poured, we will place the barriers to the bridge.
Did we lose Chloe? Is she still supposed to be presenting?
I think it's delayed on her end.
Okay.
So we'll start at the additional Benson footing at the beginning of the slide.
Okay.
Also,
Oh, I think we lost her.
We
You
just
guys might
lost
just have to pick it up. Yeah.
Okay, so on this slide for the additional Benson footings, we wanted to kind of give an overview of the section, and this is for the I-12 US 190. As you can see, there is the existing footings, which is the dotted box lines, and then you have the bolded boxes, which is the footings that are being placed. If you look in the bottom left portion, it says pile layout for footings. This gives you a view of where the piles will be placed in the footings. Then from there, the columns and the bent caps will be added with the girders and slab placed above. Next, we jump into the column and girder details. To the left, we have an example of just, one of the many columns that are going to go up. It is 3 feet in diameter, which is pretty consistent throughout the whole project. And it attaches to the top at the bent. From there, the bent actually has the bridge girders placed on top of them. Either there will be type 3 or type 4 girders with the bridge deck placed on top. And I don't believe you can see to the right, but to the right is the bridge railing that will also be placed on there. We wanted to give an idea of the sequence, and so we'll start with the I-12 over Ponchitolawa Creek, excuse me. Phase 2, steps 1 through 3, actually start with the slab being saw cut and the reinforced bars being, excuse me, being left over for butt splicing. This is actually one of the only bridges that has the bent being spliced as well. So from there, we step into step 4 of phase 2, in which we add battered piles, and then those piles will be 18 inches, and they go up to the butt spliced bent cap, which continues up to the slab being placed and butt spliced as well, with the barriers going towards the center. For the next example, we have the I-12 over the Canal and Bike Path. Just a reminder, this is the slab deck with girders. We start by cutting off and splicing the deck, and that's the phase 2 steps 1 through 3. Then we add a separate bent that is not to be spliced with its I believe those are 30-inch piles with the type 3 girders placed atop and the slab deck spliced along with it, and then the bridge railings placed on top as well. Next, we jump into the HeavyBid estimating software. Our portion, because some of the quantities were given to us and pricing, which made up close to, I think, 4 million or a little bit over that. So our bid total ended up being $8,111,090.64. Going to the bid items, we kind of broke it down a little bit. Bid item 10 through 30, which you can see on the left side, was the removal of the bridge deck. And to help protect the public and the structures below, we put in formwork for overhead protection. Then we proceeded to saw cut the bridge, then demo. What we typically use for demolition throughout the whole project was an excavator Cat 330 and a hydraulic breaker along with the crew associated with that. Then we move on to the removal of the bridge components, which is from 40 to 100 in the bid item section. Those essentially were comprised of saw cutting and demoing with the excavator as well, and the respective crews were added in. Next, we had the mobilization, which we had a lump sum of $1,248,571.50. Then afterwards, we moved to the bent excavation that was required, and we just stuck with the Cat 330 excavator, and it had a hauling price associated with all the debris. And to move into what we thought were the most important part was the precast concrete piles. The 14-inch to the 30-inch essentially had the same crew with haul prices and product prices associated with them. And later on the slides, we'll go over the material quotes that we got. So for the 14 through 18-inch, we kept the same crew, and that included pile leads, pile hammer, and 150-ton cranes. And just for precaution, we had an excavator Cat 320 with an auger tip attachment. Now for the 30-inch pile, we ended up using a D22 pile hammer to just for the larger size of the pile. Then we jumped to concrete, and this seemed pretty straightforward for crews and what was required. The first step was to build all the formwork, and then we placed the concrete with a 30-ton crawler crane, and then we broke the formwork after we were finished. After we got done pouring all the concrete and moving all of the formwork, there had to be a polish and finish crew, which was essentially just smoothing out the concrete after it had been broken off from the form. And then a special paint polish was to go over the deck of the whole structure. And there was a large sum of reinforcing steel to be placed throughout the whole project. You can see it at the bottom of the page. It was 1,106,994 pounds, which our unit price ended up being $0.67 or 67 cents. And then lastly, we covered the concrete bridge railing, which involved us having the bridge forms built. Those were again done with a 30-ton crawler crane. And then the steel was placed along with it, then the concrete placement, and then we had to break the forms at the end. So the next slide is the total bid estimate that we had came across, which was just adding the, excuse me, I'm sorry, I can't see the bottom. Move this. Which was adding just that 4 million some odd dollars to the actual, to our bid price to get the total $12,542,470.64. This was the material quote I had mentioned before. We actually had this provided to us by Gulf Coast Pre-Stress Partners, Ltd. And if you see in the top right, where it says approximate quantity, unit, and description, it helped us get our unit prices for each, and these were all displayed per linear foot.
This is our work breakdown structure for our schedule. We chose to break it down starting with each bridge, the US 190, the Ponchitolawa Creek, and the Canal and Bike Path, followed by the directions, eastbound and westbound, then inside and outside of each bridge. We will start construction on June 1st, 2020, and we will need around 580 work days to complete the 3 bridges. We planned our construction to begin each inside bridge widening simultaneously, then move onto the outside afterwards. By using Primavera P6, we are able to quickly and simply update and modify our schedule as the project advances. For now, we are scheduled to complete the job on January 6, 2023.
As previously mentioned, the total duration of this project is 578 days. In each individual bridge, the Canal and Bike Path is going to take 524 days. US 190 is going to take 526 days, and Ponchitolawa is going to take the total duration of 578 days.
Our schedule consists of predetermined weather days and holidays to help determine the most accurate completion date. We chose to work a schedule of 10 hours a day, 5 days a week. And the blue squares are scheduled non-work days, and the white squares are standard work days.
Excuse me. We have a wide range of flow due to the placement of the reinforcement steel, being that it takes 111 days. That gives us a lot of breathing room to be able to move activities around. This project duration is strictly dependent on the amount of equipment and labor we prepared from HeavyBid. However, the project can go longer or shorter, but for demonstration reasons, we chose a happy medium. We want to say thank you to everybody, especially thank you to James Construction Group and Mr. Chet Shotan for emailing us back and just answering all the questions that we had. And I'm aware Mr. Jeter isn't in the room, but I want to say thank you to him as well for taking time to meet up with us on Zoom or text or however and answering all the questions that we had. So again, we are Bamberg Builders. I'm Mason Bamberg.
I'm Nicholas Ayers.
I'm Blaine Johnson.
I'm Chloe Wallace.
And I'm Matthew Wilkins.
I want to thank everybody for watching this presentation. Are there any questions?
Yeah. Thanks, guys. Feel free to hop off mute if anybody has a question. We have about 5 or 10 minutes for questions.
Well, this
Hey,
Carl
John,
Smith
this is-
with Harry. Oh, go ahead.
This is
Go ahead.
Ryan with D&J Construction.
Yes, sir.
Go ahead,
Uh,
Ryan.
Question, did this, I guess this project didn't have y'all do any kind of calculations or estimating or scheduling for the approach slab widening for any of the bridges?
No, sir. I do not believe that we were asked to do any quantities or estimating for that.
Okay, and then one more question, the weather days, what software or what did y'all use to come up with y'all's weather days in the schedule?
For that, we were given those days by Mr. Jeter, but we also are aware we could look that up and for each state or wherever we're doing the project.
Thank you.
Carl, I think you have, right?
Yeah, this Carl Smith with Heritage. You mentioned earthwork in your opening comments. So which location had the most extensive or difficult earthwork, or what was the scope of that earthwork?
I believe it was the Ponchitolawa Creek. It actually had you removing bents in the abutment so you could add wing walls to them. And so that actually, it ended up on the ends, you had to drive more piles in that section.
So what was the heaviest piece that you had to lift for the three bridges?
Oh, sorry. The heaviest piece, I was looking in the specs for the girders, and I didn't do a calculation on the heaviest piece, but I know they reach upwards of 90 feet. And so I'd assume that those girders would definitely be the heaviest piece. And we felt that the 100-ton crane that we were using was sufficient to lift that.
Well, how far out would your 100-ton crane be picking up that heaviest piece?
We actually didn't do any. Let me restart. It would be on the in-between lane of the interstate below. So I'd imagine it'd be fairly close to not put that strenuous angle on the crane.
Who was responsible for the payment of the materials testing on this project?
I guess I'm not I'm not understanding your question. I'm sorry.
Well, typically there'll be materials testing for like concrete strength, earth compaction, and I didn't know whether that would be the responsibility of the contractor or the responsibility of the owner.
Well, I believe in the tables they have, the data tables, it gave those quantities that you'd need for strength and PSI of the concrete as well.
Did this project have liquidated damages?
No, sir.
And then one final question, your mobilization number was kind of a big number. Was that number given to y'all, or did you have to calculate it?
That was a number we were given an Excel for, and we were to calculate, and that involved hiring project managers, engineers, and the whole
And
crew.
and the materials needed for the project. So we were given those base numbers, and then we were to determine however long we needed the office on site, if we wanted an office on site, and if we wanted utilities, and if we wanted a project engineer, or we wanted a field engineer, or project manager, and how long we needed those, and the superintendent cost. Like the superintendent cost was given to us, and it was given to us by monthly cost. And so then we were to input the number of months that we needed that item, I guess.
Thank you.
Yes, sir. Thank you.
This is JD with Maxwell Construction. Just kind of a two-part question. I'm curious of the method of placement that was used for the concrete, in the different areas, how you were conveying it from the concrete trucks to the actual placement. And then secondly, like what consideration was given to, allowing the concrete to reach strength before forms and such could be stripped and then move on, how that impacted your schedule.
Well, for the curing of the concrete, we allowed that in our schedule. We had some extra days for that. We planned that.
And then I'd assume for the actual placing is we'd use boom tube for it, and have kickers and all those to make sure that the formwork didn't break as it was being poured.
Yeah. So the question about placement is like, is the concrete being pumped, or are you flying it with a concrete bucket? And then, obviously that has an impact on the cost. If you're using a pump truck, that's cost versus if you're having a crane sitting there that's able to, able to sling a bucket, I guess is kind of the nature of that question.
Okay.
To consider in the cost.
We actually had the crane set up where we had the bucket as we were laying it, as we were placing concrete.
And the question about the cure times obviously has an impact. Engineers and specifications vary on, some are written around an actual set amount of days, but most often it's whenever you have to have reach a certain strength before, especially anything vertical, before you can strip forms, that sort of thing. So it can have a pretty big impact on your schedule. So just some consideration.
Yes, sir. Thank you.
Were there any other questions for us?
All right, I think Dr. Matthews is not here. And is there any other question for this group?
Did you calculate the actual quantities of the concrete, or did you take the quantities that were given on the bid form?
So for the most part, the quantities were given. The only time I can actually remember calculating the quantities was for the bridge railings, the standard and the slotted.
Thank you.
All right, so let me see. I think Dr. Matthews is back. Yeah, he can take over. Or maybe some internet problem with Dr. Matthews. All right, if there's no question, thank you so much for this group. Well done, and we can prepare for the next group.
Thank y'all for listening to us.
Thank you.
Thank y'all.
Thank you for your time.
Have a good day.
Thank you. And I know someone has to take the host from me, or else when I try to leave, it'll end the whole session for everyone.
Yes, I think now Dr. Matthews is the host. And yeah, but I don't know, maybe he has some technical problem. He cannot, I cannot see he can turn on the video or something. And yeah, you can pass it to the next group. We have Rock Solid Construction Group, if I'm not mistaken, as the next presentation.
Okay. Does anyone know how to pass the host?
I believe it's already been passed. I already said it on the
Okay.
screen that somebody
Okay.
else.
Okay.
All righty. Well, thank you so much for your time.
Thank y'all again.
All right. Thank you. Good luck.
Bye-bye.
Yes, I think Dr. Matthews is back, and let me see. All right, so do we have everybody from next group with us?
Yes, sir, we should.
Okay, so all right, can you share your screen with us?
Yeah. Now, sorry. Did it close out the meeting or did it keep running?
I think it's keep running now.
Yeah, but did it run intermediate or did it shut down for a second?
All right, I cannot hear you well, Dr. Matthews.
Is everyone ready to proceed?
Yes, you can start. Yeah.
Okay. Travis?
You're muted, Travis. Let me unmute you.
Hello, we are Rock Solid Construction. We are independent cost estimating consultants. My name is Travis Fontenot.
I'm Dominic Brown.
I'm Hunter Golden.
Dylan Hostetler.
I'm Lance Sanders.
Rock Solid Construction is an independent cost estimating consultants. We were contracted by the Louisiana Department of DOTD to provide an accurate cost estimate as well as a schedule to help the Louisiana DOTD determine the feasibility and the progression of project I-12 US 190 to LA 59. Here's some of the project details. The project name is I-12 US 190 to LA 59. The federal ID project number is H011152. Our state project number is H.011152. And our bid deadline for this project was May 4th, 2020 at 12 p.m. Here is the cover sheet of the architectural drawings that we were provided. This particular image in the center is going to depict the bridge site US 190, starting at the left side of the center picture. We move to the center of this particular center picture, and we get a depiction of the Ponchitolawa Creek bridge. And moving rightward to the right portion of the center picture, we get a depiction of the Canal Bike Path bridge. Here is a regional depiction of the project site and where it can be located on the Louisiana map. For US 190, we noted that it is a deck type bridge, and for this deck type bridge, the westbound side, we ended up using 10 type 2 and type 4 girder spans. The westbound side ended up being plus or minus 688 feet 4.5 inches. Eastbound side utilized the same 10 type 2 and type 4 girder spans, and that particular span of section ran 679 feet 11 1/8 inches. This is another deck type bridge. This is the deck type bridge that ran over the Canal and Bike Path. For this particular span of bridge, the westbound side, we use 7 type 3 girder spans of plus or minus 425 feet, 11 9/16 inches. And for the eastbound section, we use 6 type 3 girder spans, equaling a span length of about 400 feet 6 inches.
So the deck type bridge, we had 2 deck type bridges, one over US 190 and one over the Canal and Bike Path. These deck type bridges are girder span bridges, and the benefit of this type of bridge is a resistance to corrosion and fatigue, as well as lightweight and ability to be prefabricated. And this means that they can be installed with minimal disruption to traffic and maintain a high factor of safety. So the stay-in-place metal decking, there are short pieces of corrugated steel that span the gaps between the girders. And this decking allows for ease of installation, as well as the fact that the decking does not need to be removed after the concrete is placed. The overhang jack system, it will be held in place with a piece of coil rod threaded into inserts that are cast into the precast girders. And the purpose of the overhang jack system is to provide support for the deck widening outside of the girder, as well as access to the screed rail.
Here's a screenshot of Ponchitolawa Creek. There will be 7 reinforced concrete slab spans, which equals about 175 feet for both the east and westbound bridge lengths. The slab span type bridge was chosen because of its simplistic construction and is the most economical choice for a short span structure. Also, slab spans are very effective at load distribution for concentrated movable loads.
So special equipment required for the project. We chose to go with a 150-ton link belt crawler crane, as well as a DMAG 1242 diesel pile hammer for the 14-inch, 16-inch, and 18-inch piles. And we went with a Delmag 1632 diesel pile hammer for the 30-inch piles. So the 150-ton link belt crawler crane, we chose this type of crane because we believe 150-ton capacity is more than sufficient. But the main reason we chose this style crane is due to the 260-foot boom length, and it'll offer sufficient access to all areas of the project site with minimal repositioning of the crane.
Like Lance was saying, we chose the Delmag D12x42 diesel power hammer because it provides sufficient driving force for the 14, 16, and 18 precast concrete piles. And the picture to the left is a new one, never used. Again, we chose the Delmag D16x32 diesel pile hammer because it provides sufficient driving force for the 30-inch precast concrete piles. And again, there's a picture of a brand new one right there.
As we're moving to construction materials, of course, we use 4,500 PSI concrete for both decks and the slab span bridges. Of course, we used precast concrete girders for this project. And then we also used reinforcing steel, grade 60, number 4, number 5s, and number 8s, and mechanical splices to meet all the specs and all the designs. Next, we move into the staging material. What we did is instead of having a yard and everything, we pretty much moved it into the median. That way all the material and everything would be there. So that way it'd be minimal crane movement. That way they could pick up something and put it right over there to it. The field office would be there as well. Just that way the superintendents, project manager, and stuff like that have somewhere right there on site that, if they come, they go look at what it is right there and not be too far away from it. Tool trailer will be there. That way all the tools and everything, it's right on site. Next, we move into the traffic control. In diverting traffic, we had certain different specs, so we had to use. Of course, temporary barricades will be pinned on the deck while existing barrier deck approaches slabs and wing walls to be removed and rebuilt. Of course, in the below, to the side is pretty much what it would be. And then, of course, you would have the new construction and then old construction as well. And then we're, removing and then putting in new. So.
We had a few activities that were subcontracted in this, such as the concrete special finish and striping. And we decided to go with Alfred Miller Companies for this subcontracting. They have a good reputation of doing work here in Louisiana.
Here's a screenshot of our bid item totals from Excel. You can see the removal of decks, vents, concrete barriers, and wing walls. You can also see our bid totals for mobilization, structural excavation, temporary sheeting, and the different size concrete piles. Here's the Excel bid items totals continued. By skimming through, you can see the cost totals for the Class A1 concrete, for the slab span, decks, vent caps, columns, and footings. You can also see the totals of the different types of girders, reinforcing steel, and finishes. Our total estimate cost ended up equaling a little over $14.3 million.
So as you can see, our cost markup for all bid items tabulated in HeavyBid comes out to $11,349,692.51. After adding these totals to totals provided for other various line items, the total, as Dylan said, came out to $14,301,723. And also, as you can see, the total direct cost is $9,869,894. And these bid quantity totals were taken from HeavyBid Estimate Recap Report.
This will move into our P6 of scheduling everything. Of course, to the left depicts the project activity and duration, as well as a start and end date. Of course, you know, it's pretty much the mobilization to the end of it. You know, the removal of the bridge deck, you know, then the structural excavation, and then we move into the precast pile driving, and of course the concrete deck, and then the joint seals on this page, and then it goes on to the next.
All right, here's what our critical path looks like. The work would start on April 28th. And so the way we kind of did things, obviously went demolition, excavation, then construction. So for the demolition, we chose to do all the steps for each of the bridges at the same time. So the bridge decks would all be demoed at about the same time. All the bins would be demoed at the same time, and so on. And then we would move into the pouring of the concrete, the footings, and then the piles and the big caps and decks. And here's the other half of our critical path. For the concrete decks being poured, it came out to all of them taking a total of about 418 days. So we decided to split those and do all the deck pouring at the same time, so we can cut those down to each deck being done by 104 days. For our work days, we had done 10 hours a day at 6 days a week, and it ended up taking 356 days for our project to be done. A lot of the work that was done at night due to the rules that the Louisiana DOT puts in place for working on this kind of work. And for our adverse days, we had taken the state's special provisions recommendations for how many adverse days need to be placed in each month, as well as the holidays. We would like to give a special thank you to James Construction Group and Mr. Chet Shotan for being our sponsors on this project and his help, and also Mr. Reginald Girder, our program chair, and the professional residents for his advising throughout this entire project. We are Rock Solid Construction, and that is our independent cost estimate. Are there any questions, comments, or concerns?
Okay, so now we are open for any questions from audience, panel, and faculty. Please unmute yourself if you have any question.
Hey, this is JD with Maxfoot Construction. Couple questions. On the equipment cost, rental rates and that sort of thing. In your approach to this, are you treating the equipment as if you the company that this made-up company you have, that it owns the equipment, or that you're outside renting all the equipment? And that would be like your cranes, your excavators, your hammers, that sort of thing. What was your approach on that?
we had intended for the pile hammers and the crane to be rented equipment.
Okay, so you're basically using like published rates or outside rates in your estimate for those items, correct?
Yes, sir. And we selected the pile hammers based on their impact force in pound feet supplied by Del Mag.
Okay. Your schedule, just looking at it there briefly, just want to make sure I understood this correctly. It looked very aggressive. Are you planning? Was the plan to have all the bridges being built concurrent?
Yeah. Yes, that was our plan.
So I mean, I guess that's the nature and how your schedule was set up to where you had these, the activities at the different bridges in terms of the demo and the decking, so on and so forth. That's why they were all stacked on top of one another.
Yeah. Yes.
So in doing it in that method, which obviously is aggressive and cuts down on the duration, going back to the equipment and the staffing aspect of it, you had dedicated resources, equipment at all three locations?
Yes, in the heavy bid, each thing was assigned the equipment needed for a certain amount of days. So it'd be the same if we did it. If an item was 12 days, we had to do it 3 times. It'd be 36 days. We have it built in for 36 days and then compressed it down to 12.
Right. So, I mean, and it's just important to know, and it looks like you've addressed it in that it's not, I'm not in the highway field, but I imagine it's pretty cost prohibitive to be running a crane up and down the interstate, breaking it down and relocating it, that wherever you're planning on working, it's pretty much you set it up one time. And it looks like that's how you addressed it, correct?
Yes, sir.
Yes, sir.
Any further questions?
I got a question. This is Ryan with D&J Construction. Y'all's answer to JD's question about y'all's renting the cranes. Did y'all come up with any kind of plan for when y'all can move y'all's crane from each bridge site, as far as at what position y'all are in the construction process, that you don't need the crane anymore, that you can take it out? Or do y'all plan on having the crane sitting there until the bridge is finished?
We was planning on having it there until it's pretty much done, and then pretty much hang out from there.
Okay. And then I got another question is, you mentioned that toward the end of the presentation that y'all would be simultaneously pouring the bridge decks. How far, or have y'all looked at where the nearest concrete plants and how many concrete plants you're going to have batching you concrete? Getting concrete there for each bridge deck, you need several trucks. Have y'all decided on how many trucks y'all will have coming to each pour?
No, sir. We have basic cubic yardages provided to us for both the deck and the slab span type bridge. For the deck type bridges that use the stay in place metal formwork, we allowed for a little bit more concrete, or actually a decent amount more concrete to fill up the ridges of the stay in place metal formwork. But for the most part, we worked based off of the basic cubic yardages given to us. We did not research specific concrete companies.
Yeah, so the mileage and all that, going from a batch plant, to the job site, we don't know right off the top of our head. But of course, I know in Shreveport, you're looking, probably 20 miles or so, just give or take. Nearest batch plant, at least.
Yeah, that I just on the concrete. We've had a project recently, and trucks coming were a problem with using one plant on one bridge deck, and if the trucks don't show up simultaneously in time, then if your concrete sets, then you've got to stop and restart. And we've had that problem before, so it was a lesson learned for me. Something for y'all to think about.
I appreciate it.
Thank you.
Yes, sir.
So this is Carl Smith with Heritage Constructors. You mentioned you used your concrete quantities off of the bid form. What materials did you actually do quantity takeoffs on?
The formwork is one of the main examples of things that we had to do hand calculations on. Do you want me to walk you through a specific bridge type and how we went about the formwork?
No, I will just the major item. So if the formwork was your major item.
It would be formwork, yes, sir.
So what did the hammers weigh, the Delmag hammers weigh?
Which one?
And well, both of them. And did you take that weight in consideration on the reach of your crane?
I know the weights of them. The D12 by 42 weighed 2,820 pounds. And the D16 by 32 weighed about 3,500 pounds. Did that answer your question?
Yes, sir. I mean, was that inclusive with all the accessories and hoses and everything?
I suppose. We pulled that straight off the website.
I know on the crawler crane, it was a 267-foot reach, give or take a little bit. So pretty much reach where we needed to, anywhere, the piles and all that kind of stuff were. Mobilization, at least.
Well, I'm not a bridge builder, but I know that sizing your crane properly and knowing the weight of your pieces that you're handling and the distance to your pick points is extremely critical to, organizing your project and doing it efficiently. And one last question, was there liquidated damages on this project?
No, sir.
No, sir, not that I know of.
Thank you.
One quick question, guys. This is Lou Watkins with Westlake. So you said you were working 6 10-hour days. So you figured 20 hours overtime for each one of your guys, or did you stagger your crews and maybe give one guy a day off in there and so work 50 hours, or how did you figure doing that?
We set up our labor with anything over time and a half as overtime, and anything over 0 hours on weekends would be considered time and a half overtime.
Okay, so pretty much everybody there was getting 20 hours a week overtime? Each
Yes,
one
sir.
of your guys? So a third of your man hours to complete the job was basically premium time, right? You're working 60 hours a week per, you're paying about 33% of your man hours are going to be paid out in premium time, right?
Right.
So I'm just wondering if y'all looked at that as far as that was the most efficient way to make money. I mean, that overtime gets expensive really quick. I didn't know if y'all looked at that, did some kind of cost benefit analysis or anything like that.
Well,
I mean, it's good to get finished early, right? When you got the people out there and you're paying these equipment costs, that's good. But when you're paying overtime, there's a line there, right? As far as productivity factors, what you're paying your people, what you're paying for your equipment. And I didn't know, when we're working 60 hours a week every week, I just didn't know if y'all looked at that or what got y'all to come to that, as that was the right amount of time per man to work a week.
Well, we had figured, since most heavy highway projects do 10-hour weekdays, that we would follow that line of reasoning, and we had set it up as I'd said, anything over 10 hours would be time and a half, and anything over 0 hours on Saturdays would be also time and a half.
Yeah, but if you're working over 40 hours, that's gonna be time and a half too. So that person on Friday, that's gonna be time and a half. Anything over 40.
Correct.
That's just the law, right? Okay.
Yes, sir.
Correct.
We could have done a cost benefit analysis on that, but based on what we was given and all that kind of stuff, how we wanted to set it up, we didn't take that in consideration.
Gotcha.
And in regards to cost benefit analysis, going back to the equipment usage versus the amount of man hours, we would also like to consider that as well, as equipment usage and equipment costs is going to be a significant deciding factor.
Right.
Okay. We're right at 2:30, guys. I'll give maybe one more second if there's any questions that were itching. If not, we'll move on to the next group. All
Good
right,
job, guys.
Appreciate your time. Good
Thank
job.
you, sir.
Thank you.
Thank you
Thank
for all
y'all.
your time.
Good job, guys. Thank you.
Thank you, sir.
Thank y'all.
Thank you.
All right. I see our next group guys are already on. And Jake, you're going to be sharing, correct?
Yes, sir, I am.
Okay. You should be able to share already. Go ahead and try.
Okay, let's see if we can get this to work. Hold on.
Yeah, I apologize for abandoning you guys. My power went out, then the internet went out twice. So thanks.
Can y'all all see this?
Yes, sir, we can.
Okay, how's everybody doing today? So our group was tasked for our 2020 Capstone project to act as an independent cost estimator for the I-12 US 190 bridge widening. This project runs from the Mandeville Abita Springs exit on I-12 to the Covington US 190 exit on I-12. It's roughly 3 miles long. We are DeVincenni and Sons. My name is Bryce DeVincenni, and
I'm Alex Huey.
DeVincenni Sons.
I'm Alex Huey.
Kyle Conrad.
Caleb Pierce.
And I'm Jacob Felch. So, we can get that to work. Project overview. The goal of this project is to widen these bridges and the highway for upwards of 40,000 more daily drivers coming both from New Orleans and Baton Rouge. And so this is a 3-phase project. Basically, we are acting as part of the first phase of this project. We expect this project to be $13.4 million, and it should take about 24 months. What we used on this project to make it work, the main softwares we used were HeavyBid to help us create a bid for this project, and P6 basically just to schedule the project and help us get everything as far as the timeline is concerned ready to go. So this is a satellite view of US 190, the intersection between that and I-12. And basically, it's like I said earlier, it's a huge intersection. This is a main thoroughfare between two of the biggest cities in the state. And like I said previously, the reason that we're doing this is just to accommodate for more traffic based on, you know, more people going to and from work, going to and from the cities, what have you. We're doing a lot of the work on this bridge at night to try to keep the public safe, as well as to, you know, just not shut down the highway for as little time as possible. Excuse me. We're staging this bridge specifically in the very center of the two. I don't know if you can see my mouse, but we're planning on doing it right here. There should be enough room for a crane to fit there. And for the demolition of this project, we are planning on building like a wooden structure almost to act as a net to catch all of our debris, just so we don't have to clean up any extra debris from the demolition. And our demo should cost about $460,000. For the reconstruction of this bridge, we estimated it's going to cost about $3.5 million. And this bridge specifically is a deck span. It's about 690 feet long and we're planning on widening the inside of the bridge 32 feet, as well as replacing the deck 8 feet on the outsides of the bridge. And this, like I said, it should be about $3.5 million, but that price doesn't include the non-additive items.
This is the Ponchitolawa Creek Bridge. It's about half a mile east of the US 190 bridge location. And if you look at the picture on the left, you can see there's plentiful staging space, again, between the approach for the two bridges and again along the creek. It's a slab span bridge with 175-foot length, and then it's sitting on 18-inch piles as opposed to columns and piles or something like that. It's got 7 reinforced concrete spans for that 175-foot length. The demo of the deck, band swing walls, barriers, all that kind of stuff is going to run about $80,000 on this bridge, and then the replacement and widening, which is a 23-foot and 1-inch widening on the inside, and a replacement of 7 foot and 4.5 inches on the outside, will run close to $920,000.
So this is our third bridge we'll be widening. It is the Canal and Trace Bridge, Bike Path Bridge. It's about 2.5 miles away from the US 90 to the east, and is our second deck span bridge. And as you can see on the west side of the two bridges, there's plenty of staging area on the westbound shoulder. So this is a elevation view of our westbound side. It has a length of 426 feet, and it sits on 30-inch piles instead of columns. And we will only be widening the inside part of this bridge, which will be 23 feet 9 inches, and the outside we will be doing a deck replacement of 12 feet 9 inches. And this is an elevation view of our eastbound. And this bridge has a length of 400 feet, and we'll be widening the inside and outside of this bridge. The inside will be widening 24 feet, and the outside will be widening 12 foot 9 inches. The cost of the demolition we found for this bridge was about $131,000, and the cost for completion is about $1 million. This bridge is also sitting on top of 30-inch piles instead of columns, and the total cost we found for our piles was around $580,000. And to keep the debris from falling on the bike path and the canal, like the Ponchitolawa Creek Bridge, we are using a catch net to catch all the debris.
Bryce, you're muted.
So here's our vendors that were provided by Mr. Chet Shoten with James Construction that will be used on the project. We will be getting all our concrete from Lafarge Ready Mix, which is actually roughly 1 mile from this project. We will also be getting all our piles and girders, the quotes on the right side of the screen from Gulf Coast Pre-Stress Partners in Pass Christian, Mississippi. All our steel forms for our deck spans will be coming from New Millennium Building Systems, and all our rebar for our butt splices and in the decks and everything will be coming from Harris Rebar New Fab. So here's our estimate recap from HeavyBid for all of our additive items. Most of our costs, of course, came from the permanent materials, and we as a group and from past experience came up with roughly 10% markup was a reasonable markup. After doing all our estimate for the additive items, and including the markup, we came up with $8.988 million. So here's our bid item sheet. Everything that is not highlighted in white was everything that we estimated, which equals at 8.9 million. Everything highlighted in yellow was all non-additive items where the prices for the unit prices were provided to us. And that cost for the non-additive items came to $4.431 million. And with both of those combined, our total project for all three bridges widened would equal 13.422 million.
Okay, moving on to the P6 schedule. I think I should first say that we're going to be working 5 days a week, 10 hours a day. As far as building goes, the inside of each set of bridges will be constructed and demolished simultaneously as to avoid having to possibly move the crane or excavator. As far as cleanup goes, we're going to have 1 day after each bridge is completed, as well as 2 additional days at the very end for a general site cleanup, whether that be moving materials out, finishing touches, and all that. All right, so first, we're going to demolish all of our bridges separately, and that's this first little break of scheduling here. So to throw out a few dates, I'm going to go through the demolition finishing dates first. The demolition of US 190 is scheduled to be finished on November 25th of 2020. The demolition of the Ponchitolawa Creek Bridge is due to be done July 30th of 2021. And the bike path should be done March 30th of 2022. And that is all demolition dates. Now the actual finishing dates as to when the bridges is to be completed and can be driven on should be for US 190, January the 1st of 2021. For Ponchitolawa Creek, it should be September the 20th of 21. The bike path should be May the 20th of 2022, and our project completely done May the 24th of 2022.
We just like to thank our sponsors. Obviously, Mr. Jeter has been a huge help to us. He's been, the one who taught us about estimating, scheduling, everything throughout our college careers. And without him, we wouldn't even be close to being able to do this project. As well as Mr. Chet Shotan for just helping us with quotes, helping us with any general questions we had. Thank you all so much for everything you did for us. And now we'd like to open the floor to any questions that anyone has. So this has been Divincetti and Sons, and this was our project.
Yeah, it's JD with Maxfoot Construction. A couple questions for you. First off, the markup, the 10%. I'm just curious in your estimating how you accounted for, obviously all the nuts and bolts of building the bridge, the concrete, and all that. As far as like administration of the project, how did you treat the overhead aspect? Is that just rolled up into your markup, or did any of that get taken into account in terms of your actual cost of the project?
Yes, sir. All the overhead is for administration, field engineers, project engineers, and everybody, including the office personnel and everything, got included with the mobilization as a general condition. It was roughly around $1.2 million across the whole project for the 2 years.
So your markup is in addition to your,
yes, sir.
Into your administration portion of the work.
Yes, sir.
Just kudos on your schedule. I mean, your schedule was very itemized. I mean, that's a lot of effort breaking all that down, but I think it's what's absolutely necessary to get a handle on the number of activities and how they stack up. You can fall in the trap of making big generalizations on things, but you can't really appreciate how long things take until you break it down in those steps. So that looked really good.
Appreciate it.
Can't tell you if it's right. I just know it looks good. That's all I've got.
What was the most difficult task for this project?
Difficult task as in like the longest, or as in, you know, the hardest to think through problem solving wise?
Yeah, the most difficult or the challenging.
We kind of had a few. I know that figuring out how we were going to catch the debris falling down as to why, or as to make it to where it wouldn't fall into traffic, that was kind of hard for us to think about problem solving because it's kind of hard to visualize without actually being there. Another thing was tying into the existing rebar that was in the bridge when we were doing extensions. How exactly we were going to be able to let enough rebar show out to where we could tie in with more rebar and extend out, for me personally.
What about working around the water?
Yes, sir. That's also a challenge.
The one good thing about where we're working at the water though is that they are smaller waterways. So if we had to, we could put a small little barge in there or structure where we could put equipment on. So to allow people to work under the bridge.
And again, with the water, it was pretty difficult trying to figure out how we were going to pick that sort of debris net for demolition to keep everything intact beneath the bridge, including that ecosystem down there.
Well, just about every project you bid will have a challenge that keeps you up at night. And the quicker you can identify that, the more time you have to solve that problem. But I thought you guys did a really good job of even individually presenting. And I thought you had really good detail. And I liked your graphics. So thanks, guys. Appreciate it.
Thank you.
We really appreciate that.
One question, guys. This is Lou Watkins with Westlake Chemical. As part of the bid specifications or the package that y'all got, were you required to figure performance or payment bonds? And if not, did you anyway? Did you put an allowance in there for that?
Yes, sir.
Did you say no, sir?
No, yes, sir, we did.
Okay.
We included a bid bond in there.
Okay.
And I think it was 7 or 8%. Roughly in there for that.
I see. Okay. Did they ask you to do that? Was that a part of the bid specifications or anything from in the package from the state or whoever was paying for that?
So for that, yeah. So that was one of my first questions was when we were presented was what was the pay rate? Was it Davis Bacon or anything like that? And then is there a bid bond that we have to do? Because usually both of those are crucial items to look for.
So so was there a Davis Bacon wage schedule?
Yes, sir.
Okay. Yeah, good job, guys.
Is there any other possible questions that anybody may have for us?
Looks like you got it, guys. Appreciate it. You guys did a great job. Thanks for your presentation. We have one more group. We got about 10 minutes or so. Most of them are on, but let's wait a few minutes here to see if anybody else needs to log in.
Dr. Matthews, do you need to take the host from me?
Let me double check before I say no. I don't think so. I
It
changed.
has you as host.
Yeah, I changed one of those settings so that it would just keep me as the host. Okay. Let's see. There's John. There's Caleb. There's Stephen. There's Joseph. And Andrew, I know he's on there. I saw his name. Yeah, there's his name. Okay. Andrew, you can go ahead and pull up the presentation whenever you get a chance.
Is everybody ready? Yeah. All right. We are Jack's Construction. Sorry, we're Jack's Construction Group, and our project was the I-12 US 190 to LA 59 bridge expansion project. And this is the location of the bridges. It was in Southeast Louisiana within the St. Tammany Parish, and it was in between Covington and Mandeville. It's not really in a incorporated part of the state. But there are 3 bridges along this short span of I-12. And this is the plan view of the location of those bridges. So you can see the project starts over here on US 190 and goes all the way over to Highway 59 over here. And there are 3 bridges located, one right at I-90, one over the Ponchitolawa Creek, and one over the Canal and Bike Path. And then the project ends over here. So the explanation consists of widening 3 bridges along the US I-12 in St. Tammany Parish, while also reconstructing the barriers on both sides. And like I said a second ago, the 3 bridges are over US 190, the Ponchitolawa Creek, and the Canal and Bike Path. We acted as independent cost estimators for the owners of the project. And the construction will consist of demolition of the existing bridges, only taking off small amounts of it, driving piles, extending vents, placing girders, and bridge decks where appropriate.
So first off, we had a few concerns when we began the project, some things that we wanted to address and things that came up later that we were worried about. And one of those things that we were worried about was debris falling over the US 190 onto cars. Another thing we were worried about was how we wanted to deal with our sequence of construction. We didn't know if we wanted to go do each bridge in the eastbound direction and then come back and do them in the westbound direction, or if we wanted to do them a different way and which way would be better. We were worried about how we would mobilize our piles, how we were going to move those to where they needed to be, and what we were going to use to install them. And then we wanted to make sure that our schedule was accurate and really sound, so we wanted to account for weather days that weren't beneficial to us. So some of the ways that we address some of these things, for the US 190, we're going to use these debris nets, but just in case there are some small things falling that might hit car windshields or anything like that, we were going to build we had a little money set aside in case we wanted to build a little wooden structure built up on 4x4s and some plywood that could catch these small debris. Just for reference, for kind of to visualize what I'm talking about, there's an image here in the top right hand corner. That's in Pennsylvania. I can go into more detail on that later if you'd like, but that would catch more debris, larger size, but we're doing just small stuff, so it doesn't need to be very structurally sound. And then for our sequence of construction, what we decided to do was, if you reference this lower image, you can see that we decided, well, instead of going every bridge in the eastbound direction and every bridge in the westbound, we would just do each one in one section. That way we would lower our mobilization costs. We would only have to do that half as many times as we would if we did it the other way. And then for our piles, we decided we would use a crane and then to lift them up and get them into position, and then we were going to use a steam hammer to drive those. And for the weather days, it's a pretty obvious solution, but it was something that made us a lot more confident in our schedule. Was just in the provisions, it was given how many days we needed to use for those days for every month. So that really allowed us to be more confident in our schedule and be happy with it.
All right, so for mobilization, we actually had to do this after we determined the total project duration. Once we determined our total project duration, we came through and input the values. Our project duration is 27 months, so we inputted those into the appropriate categories. We also had to worry about the field office setup and remove. We assumed that'd be at one central location, so it'd be set up once and then picked up. We also included our catch formwork, as JT mentioned in here, which we calculated to be 11,520 square feet. It's going to be reusable, so we'll be able to pick it up and move it over. And we also calculated for hauling equipment in here. We determined it would be approximately 10 to 12 moves for the crane. And so it'd be going to 3 different bridges. And we also had our excavators and other equipment in that haul equipment per move as well. So we wanted to go ahead and mention our specified unit price bid items. These were actually given to us. They came out to $4.4 million, as you can see. We just didn't want there to be a gap in our presentation where you're wondering where money was missing or where we got funds from. But this was given to us ahead of time.
Right, so this is just kind of the beginning of our estimate summary. This was given to us off of the HeavyBid program. So as you can see here, we kind of circled the somewhat more important prices here. You can see in the green circle is our unit prices for each bid item, and then in the blue is the total using those unit prices with the quantity. So if you look on the right-hand side, the first 10 bid items here pretty much all have to do with demolition. And so kind of each one had its own special crew, but for the most part, they were pretty similar. Each one had loaders, excavators, dump trucks. We included some laborers coming down to flagmen or just laborers on hand to help with any demolition. Depending on the crew, it was varying between 2 to 5 just normal laborers. So for example, some of the kind of discrepancies, quote unquote, in between the crews is for the demolition of the wing wall and vents. So that crew would consist of an excavator with a demo attachment, a demo hammer attachment to go along with it. So using that, we were able to cut down a little bit on the number of laborers we have on hand compared to something like the demolition of the deck. That one would be mostly with concrete saws and jackhammers. And with that, we would need air compressors and things like that. And then you can move on and you see bid items 14 through 17. These deal with the precast concrete piles. And for this, we, as JT mentioned, we're going to use a 150-ton crane to deal with these. The only kind of difference would be with the pile hammer. So for the piles 14-inch, 16-inch, and 18-inch, we would use a steam pile hammer with a 24,000 foot-pound capability. But with the 30-inch piles, we would use a 41,000 foot-pound capability. And as we go on to the next slide, you can see between 19 and 22 is where we start dealing with the concretes. So the way we kind of split this for pricing anyways is we decided to split it up into concrete pouring and formwork. So each one had its own different crew. And so, for example, the concrete pouring would include your concrete work tools like your screeds and everything else associated with that. And with this, there would be approximately probably 9 to 10 laborers that we included. And then with the formwork, this is where it would include, building the forms, and some of them, for example, like the concrete columns, we decided to use those big ones that you could just pretty much set in place. So that was going to help us on time. And for all that, had about 5 laborers on hand with that. And And then moving down, you can see the girder, the 2 different girder types. That one, we would use the crane as well. And with that come along with approximately 7 laborers just to help make sure everything goes on smoothly. And in association with this, I will mention that for the overhang jacks, we're going to use overhang jacks. So we assume that we would have the overhang jacks already on hand. That's something that the company would already have, but we did have to include the girder inserts. And so if you were to look at the overall estimate, you'd see that those were included in these bid items. And then going on, you can see the finishes, which would include, again, things like screeds, a water truck, and about 6 laborers on hand. And then the railings, it was pretty much the same thing as the concretes because those were cast in place. And then this is just kind of a screenshot of our bond table. You can see we have a bond rate of 10 per 1,000. And this just pretty much shows you how much that bond came out to be.
This is John Berry, and I'm speaking to you. And what you see in front of you is the schedule. We broke up the schedule into the 3 following slides that you'll see. This first one is the bridge over US 190, and that is going to be the start of our project. And that project has a duration of 14 months, starting in June 19th, 2020, and it'll end in August 6th, 2021. This was our longest bridge with a span of 689 feet. And so this was as you can see, it's kind of misleading. Our actual bridge would start in June 19th, but our project would start in June 1st. And I think that our previous groups have marked that as well. But we have a couple of days of our traffic control and mobilization for that start. So this is our second bridge. This is the bridge over Ponchitolawa Creek. It has a shorter duration, which would make sense because it's our smallest bridge with a start date of August 9th and an end date of December 23rd. And finally, this would be the last bridge that we would work on. And it's our second longest bridge, 426 feet span. And the project would span 10 months starting on December 27th and going into September 13th.
All right, so our project summary, we start June 1st, 2020. The actual start, like you was mentioning, was June 19th, but mobilization, everything has to occur at June 1st. The duration is 27 months, but the actual work performed days was 485. Our project end date is September 9th, 2022. And as you can see, our base cost before markup, taxes, and bonds was $11,022,403, and our final price was $11,754,739. Last, we'd like to say thank you to Mr. Shotan and James Construction Group. And at this time, does anyone have any questions?
So we're Jackson Construction. My name is Andrew Holson.
Joseph Allen.
I'm John Berry.
And I'm Caleb Witt.
And Stephen Kessler.
And at this time, we'd like to open the floor to any questions.
It's JD with Maxfield Construction. I'm just curious on your schedule there. You had your plan was to have all the bridges done concurrently. Is that correct?
Yes, sir. We would start one at a time, and then we wouldn't start the construction of the next bridge until we finished the construction of the previous bridge.
So sequential then. You're gonna do one and then.
Yeah, they're not concurrent. They're gonna proceed the following. So they're gonna go in order from 190 to the creek and to the bike path, and they would go eastbound, westbound, and then so forth throughout. That way we have less equipment moves.
Okay, and because I think earlier you were showing how many times you thought you'd have to move the equipment, right? That was, I think I saw that earlier.
Yes, sir, that's correct.
And why did you choose to do it that way? I mean, did you look at the 2 different options of doing, additional equipment, manpower to do, it concurrent versus sequential, or what, what was your plan there?
We just started by going in order, and we kind of just stuck with it. We never really did look at doing concurrent. We assumed it would be a little bit more costly, but we didn't actually look into that.
Did the project requirements, did that have a duration requirement?
There was no duration requirement. We were acting as just independent cost estimators and providing the owner with a schedule of what it should look like, and that's kind of what we stuck to.
Did you do any of the quantity takeoff yourself, or were all the bid quantities provided?
The big quantities were provided to us. We did, the only calculations we did were the form work for certain items, but the actual quantities that were like in Excel, so like the concrete quantities, all that stuff was given to us.
Okay. So you didn't check any of those numbers or anything there, just spot check or anything?
No, sir. That's what we were given.
Okay. I see you had a 9.9% markup, pretty well all the way down on each of your costs, each of your unit costs.
About the bond.
How did you come up with that number?
9.9%. Yeah. How you come up with your markup? And he mentioned, he goes, does that include all your overhead and like your personnel? I said, yep. I said, no, that's including.
Hey, Bryce, your mic is on right now.
We took the that number. It kind of rounded down because we typed in 10%, but we used that number because from what we noticed, that was kind of the typical average between different types of markup for things like equipment and labor. So we just took the 10% because it's looked as somewhat of an average.
Right. Once you get out in business, you'll learn you can look at those quantities and you can basically check the quantities that you're given. And if you think they're short or if you think they're over, you can play with those unit costs. And it's just a way to make your bid look good, but maybe make some money in other ways. So sometimes you'll adjust those factors on each unit cost based on where you think those quantities are actually going to end up. So just something you'll learn through as you go through in business. So it's always good, even if you're given the quantities, you need to look at that and you need to check those quantities and make sure that you agree with it, because that's going to feed into a unit cost for when those go over or those under, and that could be the difference between making money or losing money. So just food for thought there.
Yes, sir.
This Carl Smith with Heritage Constructors. What was the strength of the concrete required for this project?
What we had read was that because it was all Class A1 concrete, the typical strength for the Class A concrete is 4,000 PSI.
And how often were you required to test it?
We actually account for the testing of the concrete. Being the independent cost estimators, we assumed that we weren't required to do that part. We assumed the actual construction company that would be carrying out the project would be doing that. So we were just trying to get an estimate for the overall, what it should be around.
And so were your general conditions included in your mobilization, or did y'all take that off separately?
The general conditions as in the adverse weather days?
No, it'd be like your superintendent, your job shack trailer.
Yeah, the prices per month were given to us. We determined the duration times and then plugged it in to our Excels.
Well, thank you. Good job.
Good job, guys. Are there any more questions from the audience?
Good job.
Take that as a no. Good job, guys. Appreciate it.
Thank you all.
Thank you. Thank you.
So that was our last presentation for today, guys. I really appreciate all the industry and IAB members that were able to join, and thanks for your questions. JD, who else we have? Ken, Chet, Carl, Mitch, Lou, all you guys, I really appreciate it. I suspect Mr. Jeter will be following up for some feedback as well. I don't know if he gave you guys the grading sheets ahead of time, but I suspect he'll be in touch for your evaluations as well. So thank you guys for doing that.
Sure thing.
You're welcome. If we're done, y'all have a good afternoon.
Yeah, thanks, Carl. Appreciate it, buddy. Yeah, we're done.
Thank y'all.
Thank you.
Have a good day.
Appreciate it.